You know, it's going to be a cool YouTube video when there's a hole in the ceiling from your project.
Now get ready. Here we go.
Ladies and gentlemen, welcome to the Ryan Ride Mechanic channel. How the heck are you doing today? All right, today's video, we're going to be talking about the S&S Tower, the infamous shot towers, Tower of Power, whatever you want to call them, whatever they're called out there. That's what we're going to be talking about today. So let's get right into that. All right, if this is your first time here, welcome. I appreciate you coming and watching a video. I hope this video keeps you entertained. If it does, I've got plenty more videos just like this. For those of you out there saying, hey, something sounds a little different, I got a new microphone. Yes, this actually is a Blue Yeti microphone. I know there are better ones out there, but this is the one I decided on. So all those people that says, hey, I've got Blue Yeti experience, there you go. Still working out some of the finite things. The other thing is that I'm still getting over this cold. I've had a really nasty cough for like 2 weeks now. So if you see lots of little random edits or you hear my voice trail off here and there, it's because I have to pause the video and cough a whole bunch. But hopefully we can do this just right. All right. So today's video, we're talking about the S&S Tower. I know it's like repeating the intro over again. Sorry about that. So I've been trying to figure out the best way to go about this, and I think the easiest way to do this is to go through some basic construction, build up, and go into operation. So what is an S&S tower? These are drop towers. They're bounce towers. Basically, they can be configured multiple ways, so it's kind of hard to put them in a category. S&S manufacturers started building these things about the early to mid-90s, and parks love these things because they were thrilling. They offered a very large thrill for the guests. They were easy to install on the cheaper side of things, and they offered a really good maintenance package. Like you didn't have to do a whole lot to these each year to keep them running. So the cost of owning the ride is actually down low. So it's a really good bang for the buck. So obviously these things started springing up all over the place. Almost every single park has one. If it doesn't have a single shot tower, which is one tower, you might have a double shot or a triple shot or maybe even 4 of those things sitting next to each other, depending on the park you go to. They've made it to almost all corners of the earth. Heck, even on top of the stratosphere in Las Vegas, there is a shot tower sitting up on top of there. So a lot of people said, hey, can you do a video on how those work? They're really fascinating. Yes, they are very fascinating. And they're actually on the simple side of things and the complexity of things. So it's actually not that bad. So for this video, we're going to talk about it. I've got some visual graphics to go along with it because a lot of this stuff you can't really see. It's just kind of inside of there. You kind of have to trust that it works. And then for this, I've actually made a small demonstration out in the garage. Basically, I tried to make a one-sided shot tower in the garage. You see how that turns out towards the end of the video, but we'll get there. All right, so construction, well, let's start with the tower itself. These towers are generally square. Some of them are slightly rectangled when you look down from the top, but basically they're all square. They use 4 large square beams on the sides, and that is the main support for the tower. That is also the guide wheel surface for the cab. So the towers are made out of simple steel construction. They're latticed work on all 4 sides that go all the way up. There's really not much to them. It's just essentially a square tower standing up out of the ground. There's nothing to it. In the middle of the tower, if you look at it from the top, say it's a big square with nothing in there, in the middle of the tower there is a giant, round, of course, tube that sits in the dead center of that tower. What is that tube? Well, that tube is actually several tubes put together to make a tank. That is an air tank. The entire ride runs off of compressed air. So the entire thing is compressed air driven, so it needs a very large reservoir tank to feed it. S&S rides that are air driven, they use a ton of air. That's a high CFM, or cubic feet per minute, rate that the air compressor has to put out. Now, maybe I should pause and talk about that for just a split second. In the back, outside, away from the ride, typically there's a building installed nearby. They use 1, 2, 3, 4 air compressors back there. Now, these aren't like your garage air compressor at home that's got a piston inside that's moving up and down, losing its brains inside there. These are high volume screw drive air compressors. These things run off of, they pull air and liquid in at the same time compress the air way down, eject the liquid, and then take the liquid that's left over back out with a giant filter, and then you just have clean compressed air on the other side. Now, compressed air is naturally filled with lots of water because of the moisture in the air. So then that compressed air has to go through a compressed air dryer, which is essentially running the air through a refrigerator. Once you run the air through a refrigerator, the water falls out of it, it collects, the water gets ejected, and you have nice, clean, dry air. Why is dry air important? Well, dry air does not corrode things as fast as everything else. Air assemblies are kind of hard to deal with because when they get moisture on the inside of them, they will basically water the valves from the inside out. They will corrode, they will rust, they will get all sorts of porosity and things building up inside, which can actually reduce airflow and cause valves to malfunction. So air assemblies sometimes are hard to keep lubricated for that reason. Some air compressors have auto oilers installed. That's where they push oil out through the line. But because of the size of these rides, trying to get a tower that's almost 200 feet high to get oily air to the top of it, it's pretty much impossible. You could shove air through the bottom, it'll fly up and then come right back down, just create a big oily mess on the inside. It's not a big deal. So behind the scenes, giant air compressors, plural, running the thing. Now, could be 1, 2, 3, 4. It all depends on how the park wanted to install it versus what S&S recommended. S&S might say, here, you buy this giant screw compressor and the ride will work just fine, and the park will do that. But somewhere along the line, sales said, you know what, to keep your ride up and running and just in case and reduce the stress on your air compressor, you should buy another one and run them in parallel with each other. Some parks go a little bit further and they actually down the size of those air compressors and they'll put in a bank of air compressors. That's 2, 3, 4, 5 air compressors in a row and literally run them one at a time. So today you might run compressors 1, 2, 3. Tomorrow might be 4, 5, and 1. And you just keep the rotation to keep the hours down low on some. That way you could do the maintenance on those things. Those air compressors do eat up a lot of money when it comes time for their servicing, but they're not really like an annual thing to do to them. As long as you keep the filters and strainers and stuff clean, they're pretty bulletproof. They last a very long time, especially if they're made by Ingersoll Rand. I've always had good luck with that company. Anybody else out there have good luck with Ingersoll Rand? I've always had good luck with their stuff. Okay, so back in the tank, we have this giant cylinder in the middle of the tower out there. That is the air reservoir. Now, back in the back, there are also more tanks back there next to the air compressors that also store air. And I'll get to the difference between those tanks when it comes closer to the operation. So in the center, you have an air tank that holds a bunch of air pressure. On the outside of that, dead center of each panel, so you have 1, 2, 3, 4 panels of the tower, dead center of that, there is a smaller tube. Most all the rides, the big tube in the center, the tank, is painted red. The smaller tubes are painted yellow. So the examples I made are pretty much the same way. So the smaller tubes are called, well, the people I've talked with, they're called shot tubes. So this is what's necessary to make the actual ride run. So the shot tubes are just that. They are simply just a tube. That's it. It's just a big tube with nothing in the middle of it. 4 of them sitting behind there. Now, the deal with why 4 of them is because it takes 4 components to run the ride, 4 drive systems to run this ride. I believe 2 are to keep it level, 2 are probably for redundancy, but when you have all 4 work together, your pressures and everything else drop down really low and manageable. It makes the system really easy to use. Top and bottom of those tubes. The top and bottom of those tubes, there is a giant pulley. I wouldn't say giant. It's actually about 2 feet in diameter. There is a pulley at the very top. There is a pulley at the very bottom with a steel cable. Now, despite what I've heard, that they were some sort of fancy cable, I've talked with several people now, and they are just standard right lay cables, steel cables that go all the way up and down, and in the center of the tube, it connects to a piston. Now, the piston isn't really much to look with. I actually had somebody from a park, they actually sent me a picture of the piston. Unfortunately, they said you can't use that picture. And I respect those wishes completely. I said, thank you very much. Deleted the picture, deleted the email. So it's like, okay. But I got the concept of what it looks like. It essentially looks like, oh, here we go. Could use this guy. It essentially looks like a cylinder, kind of like this. On the picture, it was about 10 inches in diameter, which if you think about that, it kind of looks like a giant coffee can, like a Folgers coffee can. But it was essentially a cylinder just like this, and it had a metal lip that protruded out just a little bit, probably about a thumb's width. All the way around the top, that would be a sealing ring, and it also had the same sealing ring around the bottom. That was the piston, and the cable attached to the piston on both sides. Now, the piston is your mover. That's what actually travels up and down inside those shot tubes. Those cables, or the cable, actually it's two cables because it's basically one attaches to the top side of the piston, one attaches to the bottom. They go out the shot tubes and they go around the pulleys and they come back down and attach to the cart on both sides. Now, the cart is the thing you sit on. It's what I commonly refer to as a gondola, but per S&S terms, this is actually a cart. So it attaches to the cart on the outside with a series of thimbles and cable ties to hold the whole assembly together. It's really basic stuff. That's one thing I like about this manufacturer is that they use stuff that looks like it's easy to get a hold of. Like if I break components in the ride, I mean, we shouldn't be doing this in general, but if I break components in the ride, I don't think I have to go back and find something crazy that was custom made somewhere. Some of the stuff for sure absolutely is, but a lot of this stuff looks like off-the-shelf parts that I could go to a Grainger MSC or something like that and find these parts and order them and bring them back in myself, maybe to have them on the shelf or something like that. All right, so let's talk about the cart where you're sitting. The cart has multiple people can sit on multiple sides. A lot of them run 3, 2, 3, 2. But there's also other configurations where you can run 3 or 4. The cart is circular, and it can seat a lot more people around. I believe Hershey Park has one of those. The restraints are your standard over-the-shoulder restraints, steel with foam padding on them, goes to a hydraulic cylinder behind there with a safety belt to latches over the front. There's really nothing too fancy about these things. They are monitored on board while the thing is in the load position. The PLC on the cab is active, and it's watching the restraints to verify that they open, close, do all that stuff. So the safety is once it disconnects from that load position, there's no electrical power to unlock the restraints. Engineered safety, right? In that load position at the very bottom, it sits on 4, I believe maybe it's 2 per side. I think it's 2 per side hydraulic / pneumatic accumulator shocks that basically just help it go from the reclining or the lowering down to the seated position. Once it's at the bottom, it uses a series of electromechanical pins sticking up that the cart sits down on top of and makes contact to allow to transfer power and signal from the PLC into the cart itself. All right, so let's talk about the basic operation of the ride. Now, the ride's configured in multiple ways. You can have the ride launch up, you can have it shoot down, you can have it bounce a lot, you can have it re-energize and go to the top. It's all just a question of valving of what they put in the ride for what the customer wants. So there is a lot of variations and nuances that are going to be really complicated to go through, and I don't think we need to go into all of them. So basically, I just want to start and talk about the start and stop of the ride, because those nuances in the center, I feel like we're going to get too far off topic. It could take forever, and pretty much no one will care. So let's talk about when you start the ride, you go from the load position to the weighing position. So what this does is this uses air pressure from the back, from those canisters in the back of the ride, and it uses air pressure up through the bottom and says, let's push the air into the 4 shot cylinders because the pistons are up at the very top. And as we put air in those 4 shot cylinders, it's going to lift the cart up off the ground. Now, the cart will lift up about 8 feet into the air, and then it stops. And when it stops there, it's hitting a sensor on the side of the tower. That is its weighing sensor. Now, what it's doing is not actually weighing the cart right there. What they've done is they've done a process at the very beginning when they commissioned it. They said, okay, we're going to feed air pressure into it, and once it starts lifting off the ground, it says, okay, that took, let's just make up numbers, obviously here, that took 30 psi to lift the cart off the ground, and it will continue to lift all the way up. So once it starts lifting off the ground, they say, okay, 30 psi, we've got that there, and it goes all the way up, and like, we know where that is. The next thing we're going to do is we're going to say that it takes X amount of time to get from its ground position when they open the valve to that proximity sensor, that weighing proximity sensor. And they say, okay, we now have a time value between here and there. Now they have to redo that with the maximum amount of weight on there. So they will load up sandbags in all the seats and weigh the cart down as much as possible and repeat that process. And then they will say, okay, we can get it off now here at 50 psi. It takes 50 psi to get the cart from the ground up to the weighing prox. And when it does that, it says, well, let's see, it took 12 seconds to do. Okay, so they have to unload it now, run it at 50 psi again. Now, at 50 psi, when they energize that thing, the cart goes up really fast to that proximity sensor. Now it only took about 7 seconds to go to the proximity sensor. Now they have their defined boundaries. An empty cart takes 7 seconds. A fully loaded cart takes 12 seconds. So between the 7 and the 12, that is their weight variance. Now, what happens once it gets to that point is that computer has a scale in the background that it will run. And it says, what is my time value? My time value is 10 seconds. And the computer says, okay, it's loaded pretty heavy. Let's go ahead and feed you 75 psi. Now, what it's doing is it's feeding 75 psi to the shot cylinders for the actual start of the ride. Well, it's not actually in the start cylinders. Right now, the air pressure is actually coming from the tanks behind the ride. It's going through a set of valves and going up to the top of the ride and into those shot cylinders to do this weighing process. Now, if you hear at the start of the ride, right before it launches, you'll hear it sounds like a bunch of air, kind of this hollow sound, like this.
Well, you're not going to hold her hand no more, huh? Keep gonna head all the way back in the headrest now. He said, no.
What that is that is the air pressure coming from those back containers, those back tanks back there. That air pressure is now going into the main holding tank. That's the big tank in the center. So when you're being lifted up to the weighing point, the ride is actually using the tanks in the back, but it's not using that big center tank. It's using just a bypass. It's another airline that goes up the side of the ride. It's a very small airline because to do the weighing process, it doesn't need a ton of volume. It needs pressure. So high pressure, low volume. So it can use a small line, and by small, I mean on those rides, I mean it's only about 3 or 4 inches in diameter, all the way up to the top of the ride to feed those 4 shot cylinders. Now, that's still a lot of air pressure needed. There is a lot of volume. The pistons have to move 8 feet, which in a pipe that big, to move that piston 8 feet, that is still a lot of volume. That's no small task. But that's nothing like moving 150 feet, which is going to come next. So once the computer has its measurement and says, okay, we're going to put into the main tank now, we're going to put 75 psi into that tank. That is when you're sitting up there at that load position, at the weighing position, and you hear that air start to rush in, that in the background. That's the air going into the big tank because those 4 shot cylinders need a lot of volume. Now, you can't run small little airlines, only 4 inches diameter, all the way up the ride. That's not going to work. So they put a whole nother air tank into the center. Now, for safety purposes, they do not leave that center air tank energized. They valve it off and exhaust it during the entire time while the ride is being loaded. That's what's preventing it from just randomly taking off on you. The valves that are capping back the other for the lifting pressure are very well guarded with multiple valves in front of them, so they don't have to worry about that. It's got the safety inside of there. As far as the main tank is concerned, it's valved off and empty while it's just sitting there. So you get in the load position, you go up to the weight position. The valve at the bottom is a variable valve, which is basically a butterfly that sits there and opens and closes. Now, it will take system pressure, which is probably around 150 psi in the back. It will take system pressure and crack open that bottom valve and flood all the pressure into that big main tank in the center. And there is pressure transducers, which watch the pressure. And when that pressure gets up to about 70, 75 psi, that valve then shuts and says, okay, there's all the pressure we need for this particular run. Now, all it has to do on these things is one shot. This is the majority of them. They just do the one shot. That's the main shot up. So while you're sitting there at the weight position, all four valves on top, because each shot cylinder is independent, all four valves at the top will suddenly open and let all the air pressure from the main tank go into the shot cylinders, and it pushes all four pistons down simultaneously. The system is actually very forgiving on its pressures because all four of those shot cylinders are joined to the same air pressure tank. So it levels itself out instantaneously as soon as it opens. Now, can you cause damage to things? Absolutely. You can not open one of those valves, and then you'll be dragging one of those pistons across no air pressure, which puts stress into the cart, which is not a good thing. So the stuff I don't know about there's probably some safeties to say that each shot cylinder has pumped up with pressure, and if it doesn't quickly as soon as you start the shot process, it's probably going to shut the ride off. But that I can't speak for 100%, but it's one of those design things. I can almost guarantee you something like that is in there. One thing I thought about just now that I'm probably going to get questions on, so sorry. The shot cylinders, they have a cable going in and out of the bottom. How do they cap that? How do they hold that air pressure in and still let the cable through? Well, it's basically just a cap on top with a hole where the cable goes through, and the cable has a set of sealing glands on the inside. Now, I know how they do this on several other rides, but basically what they do is they basically take a silicone tube, essentially. You could think about it like a tube, and they clamshell it, which is where you cut it in half and open it up so it's in two pieces. And you put that silicone tube around the cable, and then you squish it down in a recessed hole in the center. And once you squish that down in the recessed hole, that tube squishes around the cable to where it just barely touches. Now remember, those cables are greasy. They got to keep those things greased to slide through those seals. But once you do that, that air compressor with the system puts out so much volume of air, you could have no seal in there at all. The thing will probably work okay, but it'll be letting a lot of air out of the top, but it'll probably work okay. So now we've started the process. We started that shot process. You go up whoosh, to the top. Now, what's the one thing that a lot of us hear that you know how the things reach the top? It goes all the way up there, and you hear that.
There you go.
That big puff of air. It sounds like a big thud. Well, those rides up at the top, what they do is the cylinder passes by either an opening in the side of the shot tube, or the valves go into an exhaust muffler, a giant muffler essentially. It's got baffles on the inside, and when that air suddenly comes out of there, those baffles slam to the outside to absorb that air pressure and safely let it out. So basically, it's an audible muffler. That's all it is. They don't care about the air leaving fast. They needed the muffler so you don't blow people's eardrums out. Anyone who's been around max force, Once that thing lets its air pressure out, it's got no muffler on it. It's just straight air out. That's why you get that boom from across the park. The air just suddenly leaves the cylinder. They didn't put a muffler on it. Well, the design of that muffler is different per ride depending on which one you have. So the muffler might be coming from exhaust valves. The valve opens up, or it could be coming from the shot tube itself off to the side and coming down. I believe the majority of them are off the shot tube where it passes by some holes in the side of the tube, and then the air comes down. The mufflers are actually closer to the ground because they can get clogged up, which will affect the function of the entire ride. Now, once it goes past the point and the ride exhausts that air pressure, you now have no air pressure forcing the cab up or forcing the cart up. I always want to say everything but the word cart. Sorry. Anyway, so you have no air pressure now forcing the cart up. So the cart is allowed to slow back down at the rate of gravity pulling against it. So you get that 0G feeling where you're just coasting up and then you come back down. Now, when you come back down, that piston that was under pressure, pushing pressure down on the thing, that piston that was under pressure is now coming backwards, but now it's coming backwards against a sealed system. So now you have 0 PSI, and that piston is now compressing everything in that tube to an actual pressure again. Well, what does that do? That creates a banjo effect. That creates a bounce in the entire thing. So you're watching the air pressure, it'll go 75 PSI, roughly. It's going to be dropping the entire time the cart's going up. So you're going to be 75 PSI going down there, and then it's going to go 70, 65, 60. And then once it goes past that exhaust port, it opens up, that pressure goes to 0. As the piston comes back up, it's going to start going 5, 10, 15, 20, 25, 30, 35, and compressing that air again. You get a bounce, maybe 2 or 3, and then the system goes into exhaust. So it opens up very small valves at the top and start to exhaust all the air pressure out of the system. Now the exhaust, there's 2 ways to do this. One is to open up 4 exhaust valves on all 4 shot tubes to let the air pressure out. The easiest thing to do, I can't speak for this though, the easiest thing to do is to put 1 exhaust valve onto the main tank that's in the center, because that tank has to drain down as well. So you might as well put 1 there, let all 4 shot tubes equalize in pressure, and let the pressure out evenly amongst all 4 to keep the cart moving down the tower evenly, smoothly, all the way down to the bottom, because you have to control that rate of descent so that it doesn't run into the shocks at the very bottom and hurt people, essentially, because it's like falling on your butt when you hit the ground. So they have to control that rate of descent very well. Now, a lot of people, I know I'm one of these people, I always wondered, like, well, how come when you get on those rides, some of them go up to that like 8-foot position, when you're being weighed? Some of them stop there and just hold the cart there. Some of them go up and they stop, and the cart slowly comes all the way back down, almost to the load position again, before it takes back off. Is that part of the program? Actually, no, it's not. It goes up and it stops, and it can hold it there, but the ride doesn't care if it stays there. So once it hits that proximity sensor, it stops. It knows what it's supposed to do. I feed pressure in. I raise my pressure up. Once I have enough pressure, I let it go into the tubes. It doesn't care where the cart is if the cart's slowly drifting back down. So what you're seeing there is once you go up to that weigh position and it stops, the valves filling the shot tubes at that point, those valves shut off. And you're essentially left where you are based on the seal of all 4 shot tubes. Now that's the seal of the pistons in all 4 shot tubes, and then at the very top, it's the seal of the wire ropes on all 4 shot tubes. So essentially, each piston has 2 seals on it. The wire rope has a seal on it. So that's 3 per shot tube, 3, 6, 9, 12. So essentially what holds you there is 12 seals. Now, I'm not sure what S&S's policy is on how much that system can bleed off, because that where you're sitting right there when the thing stops and it weighs you, that is also a function of your emergency stop as well. So as you're going up on a tower, when you hit the emergency stop, that tells all the valves to shut. Everything shuts, and it simply just caps all the air off. It caps all the air everywhere and stops moving air, because as long as there's air in the system somewhere, the cab is essentially going to stop wherever it is. If I have no air to push the piston down, it can't go up. But if I don't let the air out that's holding the piston in that position, it can't go down either. It's stuck right in the center, so it's a safety thing. As soon as you hit the E-stop, all the valves shut. None of the air leaves. You don't want to evacuate the air because you want it to stay right where it is, but you don't want to add air either. All the valves shut. So on a cart that leaks a lot of air, you're going to hit that E-stop. It could be 30 feet off the ground. Eventually, after a couple minutes, that thing will come all the way back to the ground, and hopefully whatever the problem was has been resolved, because it's not staying where it was. Now, different variations of the rides, there is simply just, if you want to take it to the top and then shoot it back down, just think about the process we did where we said we're going to weigh it. Say, okay, we're going to weigh it, and then the top down ones probably don't actually need to be weighed. That part I don't know at all. Guessing top of my head here. So what you do is you say, just like you would go up to the weigh position, but I'm going to use a lot more air pressure now. Instead of my 50 psi, I'm going to use 60 or 70 just to make the process quicker. And I'm going to bring that cart all the way to the top, and then I'm going to stop it up there. And then once I stop it up there, I am going to drain the pressure that was in the shot tubes. I'm going to drain that. And then at the same time I'm draining that, I'm going to then suddenly fill the other side of the shot tube. That would push that piston up, which would pull the cart down really quick. Now, those have a lot more valving inside of them, because now I'm pushing against the other one, and I'm going to open the exhaust for a little bit on the other side, and then I'm going to shut it and shut the input source at the same time. Go to both of them at the same time. And that delta that's between the two air pressures, that's going to be my bounce in the center. That's where the cab's going to live, or right there, the cart. Man, I cannot say cart to save my life. Anyways, that's where the cart's going to bounce, right inside of there. So you're going to hold it there. The only one that's different, I'm actually close to it. It's one of the very early models out here at Worlds of Fun in Kansas City. There is a ride called the Detonator. It's a very early revision. In fact, I think when I looked at it, it was the third one that S&S built. So it goes through its whole thing, but it does not use the return cable. You know, at the bottom of the piston, you had the top lifting cable and essentially the bottom return cable. Well, this ride only uses the top lifting cable. And it's like, what? Wait a minute, how does that work? Well, instead of coming out of the top of the tower and coming back down to the bottom of it, that actually goes up about 3/4, about halfway up, a little bit more than halfway, and it comes out of the top of the tower right there at the halfway point. It comes back down. But halfway up, I'm going to say halfway, it's probably more than that, but halfway up, it doesn't just use the return pulley at the top of it like that. It's actually got another pulley on top of it like that. So there's two pulleys right next to each other. And what happens, let's see if I can use an example here. I'm going to use my cable like this, right? Okay, so what happens is as this thing is coming up, and as the cab comes up on this side, I'll use my hand here, as it comes up between the two, it passes this pulley assembly right here, and actually goes from being pulled to it's suddenly on the other side, and it allows it to go back up. So it's the same principle on this side. You were taking this on the inside in the shot tube, and you were pushing air pressure down on that piston, and it was going up. But the difference is, instead of just going up completely and not having anything to stop against, eventually it passes its other side and continues up. in which case the pressure that was pushing that down is now also going to catch the recoil of that. So they only had to energize one side of those shot tubes with those early revision things because they had no return cable on it. That was really interesting to find out. All right, I know I've bored you guys to death, I'm sure. All right, practical demonstration to the shop. All right, so let's narrate through these slides a little bit. Got this old garage door opener, ordered some pulleys and some bearings to make the trolley out of here. Had to measure everything out to make sure it's fit. Ordered everything off Amazon. Did my drawings best I could. Getting the hardware set in for pulley 2. Got the bolt threaded in there, the spacers and everything, just like that one over it. It's upside down. Ach, du lieber. All right, it's fixed. A lot of mechanics hate that when you have hardware facing different directions. It's not an OCD thing. It's just that you put everything in all different directions. People tend to get the idea that you put it together not knowing what you're doing. A little bit more work on the tube in the back. Getting the piston machined out now. There it is. Seems like a loose tolerance. Seems good enough for me. Getting the shot tube all figured out for the back. Getting my material laid out. Starting to make the control system for it. And I originally wanted to do this out of relay logic. So I started building all the relay logic for it. Then I was like, you know what? I'm going to use a PLC instead. All right. Let's see if we can put this guy in here. There we go. It all seemed like it was going to work at the time. Here's me fabbing up the trolley, getting it ready to go. Adjusting the park position sensor. Energized. Okay, got the pneumatics mounted up there. Want it to be as short as possible to get to the cylinder. And because it's pretty warm now, I adjusted the tension on the cable to the trolley. So hopefully that'll be good. All right, so here's the final. I've been playing with this for a while now, trying to get it adjusted, but the big problem is that on the air tube in the back, there's an interference fit right up here. No, it's not because of the zip ties or anything. It's just the cylinder is just a hair too small because of the inaccuracy of PVC up there. So what I get is I get the trolleys bound up down here at the bottom a lot, so it has to be helped. If I turn the pressure up to free the trolley, it rockets up so hard that, well, I tried putting a lot of weight on it first, and then it rockets up so hard that it breaks the weight supports, and yeah, so we don't want to turn the pressure up that much. So right now I've got it set at right about 50 PSI, and that kind of works. It needs some assistance, but this is essentially basically a replica of a shot tower of one of the S&S like freestanding towers there. This would be one side of it, okay? So the way this works is that the air pressure comes in, it goes through 3 valves right there. Three valves total, it goes through 2. So once it comes off the main line, it goes through a regulator right there. Then it goes through this weigh pressure valve right there. So what that does is that when you start the ride, that takes your gondola, this would be your gondola down there, takes your gondola and basically lifts it up. Now it starts a timer from the bottom to this proximity sensor right here. And then as it gets up to this point, basically it flags that proximity sensor right there. Now I try loosening everything up, trying to get it to move freer, like so everything's loose. It's not great, honestly. Once it makes this proximity sensor right here, the computer says how much time did that take, and then it directly relates to how much pressure goes in the cylinder. So since I only had pressure one way, I didn't have a variable valve, what I did is I regulated the trim pressure coming up to say I could regulate that at a lower pressure. Ideally, I had 50 PSI in the system. So ideally, the trim pressure to get the cab up to this point, It would be, let's say, 15 psi, and it would float right up to there, and it would be good. And then at that point, it stops. It floods the ride's main cylinders. It floods the ride's main air tube that's in the center of the tower that runs up and down the very center of it, not the four shot tubes, not these guys right here. So once it puts air pressure in those cylinders, the last thing it does is it comes up to its agreed upon pressure, and then the main valve up on top, which is that guy, main valve energizes. Now when the main valve energizes, it pulls your cab all the way up to the top. Now what happens is there's another sensor along the way, and it could be done off of sensing, it could be done off of time, it could be done off of RPMs, off the wheel. It can be done so many different ways, it's crazy. But basically what I did is I used a sensor up the tower to say, hey, right here, we're going to shut all those valves. And that's basically when we go into the exhaust. Now the exhaust here, unlike a real ride, this is the exhaust right here. When the piston passes by this, on its way down, there'll be air on this side. When the piston passes by this, it literally blows the air out of the back. And then the piston stops here because of gravity. Gravity wants to pull the thing back down. That's where you get your free rise, back down to fall there. And then this side starts to pressurize again. And this is where you get the bounce out of the other side. This is where the bounce comes in back and forth. And then I have this guy set to where 3 seconds later, once we've killed the air, started the bounce process, it opens up the third valve, which is the exhaust valve right there. So it opens up that third valve, and then the cab will slowly bleed off and return back down to the bottom. Now, because of the inaccuracies in the PVC, I can't quite get that whole sequence to work like the ride. Sorry about that. I'll do better next time. But let's give it a shot. Okay, so again, I'll have to assist it the first little bit. Sorry, YouTube. I'll do better for the next one, promise. So we got to assist it up that first little bit, but basically right here, we're just going to hit the start button. Now you hear that starting to put air pressure into the cylinder. It's trying to lift this, but because it's mechanically bound, it can't basically. So I'm going to help it along until it reaches this guy. Then it waits 3 seconds. And then basically right there, it's triggered that prox. And then this is where the bounce would happen here. Then it goes back down to the bottom. I tried for this video. I tried. Next one, I don't know, I guess. So what I did was when I made the piston, I put it through a couple of inches of the PVC, and it had a nice loose fit to it. So I was like, good. And then when I got that really tough spot in here, I thought, oh, maybe it's because of these clamps that I had on there. The PVC is being pushed in the oval. That wasn't the case. And I tried a bunch just to exercise it back and forth, trying to get rid of those spots. Couldn't get rid of those spots either. So that is what I'm left with. So I'll do it again. Got a little bit of a bounce out of it that time. Let's see, it's just the whole assembly is too tight. Next time I make a ride in my garage, I'll make it looser. I was worried about the air bleeding out and not having enough valve pressure to actually get that guy to move at all. So it's kind of nice to know that it was not only had plenty of pressure behind it, but I could have made it a lot sloppier than it was and tightened up the tolerance on a lot of other things. Okay, I was able to do that with only minor structural damage to everything, so that was pretty cool. I hope you enjoyed it. I hope you enjoyed the video. Like, subscribe, share, do all that stuff downstairs. It does help me out. I do appreciate it. Should I continue on to make stuff? I mean, I don't know. I kind of like that one it made me upset that I was like, oh man, it fits some places but not others. Are you flipping kidding me? Man, I really thought I had that one. Now I just got 2 holes in the ceiling from it. Ugh. Anyways, I'm Ryan the Ride Mechanic. Stay off the air gates.